On Thursday, we started Chapter 3. I gave this in a handout, so make sure you ask for it if you were absent. But we're talking about quadratic functions in this handout, and those make parabolas, as you see. I have a bold statement right there about that. So we have a parabola that could possibly look like that. It's just a random parabola. And here's another one that's opening up. So two potential parabolas there. And we talked about this point right here and this point right here. So one question, is that a min or a max on the left graph? And I would say it's a maximum. So it will never stop going down. There's no minimum spot because it's going to negative infinity. But it does max out at that spot. That spot's also the vertex. So it's the vertex and a maximum. And on the other side, on the right, that is a minimum. It will never go lower than that spot. And the vertex. Something else on these parabolas that we're going to look at is the axis of symmetry. And that cuts right through it. That parabola wasn't the best parabola. It's not very symmetric, but you probably get the right idea. And that is the axis of symmetry. And there's one over here. This parabola came out a little better than that one. I hope this is review for you. If not, hopefully this is making sense. Make sure you ask questions when you come to class if you have them. We looked in greater detail at this specific type of form. Our textbook, for some reason, I don't know why, they call it standard form, this right here. But I call it vertex form because if it's written like that, you can see what the vertex is right off the bat. So here is the x of the vertex, and here is the y, and I wrote it right here. So HK is the vertex. Notice there is a minus sign right there, and over there in the coordinate, it's just h, not negative h. So whatever sign is right there where the arrow is pointing, you want to flip the sign for the actual vertex. I think you already know that first blank. If the front number is positive, it opens up, and we already looked and saw that it has a minimum in that case. And if the front number is negative, it opens down, and it has a maximum. So that's stuff you probably already know. If you don't, there you go. This right here, your teacher in Algebra 2 and probably Algebra 1 probably went over it, but in case you've forgotten, yes, that's how to get the axis of symmetry, but it's also how to get the x value of the vertex if the equation is in this form right here. If it's written like it is above, where that arrow is pointing, if it's like this, no need to use a formula. You can see the vertex. But if it's all simplified, like I wrote down here, then x equals negative b over 2a is a nice quick way to find the x value of the vertex. Otherwise, you got to complete the square, or I guess you could type it into a calculator and look at the graph, but depending on the type of parabola, how complex it is, it may not be easy to see. So We need to go over finding intercepts, but I think it's a little easier to actually work a problem than to just talk about it. So let's move on to number 1. So in number 1, we have a quadratic function that is in vertex form. You notice you see the parentheses and the square. This is vertex form. So right away, you should be able to tell me what the vertex is. And if you need to, look at that previous page. It's HK. So in this case, it is 3, 8. Which naturally means the axis of symmetry is x equals 3. Unless it's like a sideways parabola, the axis of symmetry is always x equals whatever the x of the vertex is. If it's a sideways parabola, then it's y equals the y, but we'll look at those down the road. Those are weird. So make a dot on your graph paper at 3, 8, and then draw a line through that representing the axis of symmetry. And I need to make a parabola. It would be incorrect if I was to just randomly draw a parabola like this. Kind of like I did earlier on that front page. I need to be more specific. I need actual points. So if I was to find the x-intercepts, that'll give me 2 more points. It's tricky to find the x-intercepts. You make the y 0, so I'm going to make f of x 0. Copy the rest. And we got to simplify. So you probably did this back in Algebra 2. There's a reason why we teach y'all to factor, if it's possible to factor, because it's a fast way to find the x-intercepts. Remember, the x-intercept is also called a 0. It's also called a solution. It's also called a root. There's probably another name for it, but those all mean the same thing, x-intercept. So I'm going to do a little bit of simplifying. Multiply out this x minus 3. So maybe hit pause and do all this, and then try and factor it, and I will do it right here. If you can do this the fast way by skipping these 2 steps, go for it. People have been looking at me like I'm crazy when I do that, so I'm going to just work it all the way out. Then distribute the 2. So we get this far, and now I need to factor it so I can see the x-intercepts. And you're going to think I'm crazy, but we got to factor out that negative 2. So take a moment and take out that GCF, and notice we did not waste time multiplying by negative 2, because we got a different result this time. And it's all because of that plus 8 right here. I had to pull that 8 into the expression, into the situation, because it wasn't included above. So I had to multiply, add it, and now take out the negative 2. All right, almost done. I need 2, whoops, let's go back to red. I need 2 numbers that multiply to 5, but add up to negative 6. And that is negative 5 and negative 1. So we know we have x-intercepts at 5 and 1. Make a dot there and there. And now we have our parabola. So as you get more experience with this, you can go a little faster. You can skip some steps. But factoring, if you can factor, sometimes you can't factor it, is a good way to find the x-intercepts. Let me show you one other way on the calculator. So if you open up the calculator, go to a graph, type in -2 x minus 3 plus 8. So that looks just like we had a second ago. And we have a parabola. And this is pretty obvious that it crosses 1 and it crosses 5, but it's not always obvious. It might fall between the hash marks, the tick marks, whatever you call those. So one way to get the calculator to do this for you is you could press Menu, Analyze Graph, and click 0. Remember, an x-intercept is also called a 0. Now, this is tricky to figure out. So it says in the bottom left corner, lower bound. That means click to the left of the x-intercept. Now you can go click anywhere to the left, but this is not the left. See, I think the x-intercept's right there, so I'm going to click a little bit to the left of it. Now it says upper bound. I'm going to click a little to the right of it, and there it is. Let's do the other one just to practice. Click to the left. See, I think it's right here. I'm going to click to the left of it, click to the right of it, and we have it. There's other ways you could use quadratic formula. There's probably another way I'm not thinking of, but all right, hope that made sense. We'll do more after Thanksgiving break. See y'all later. Have a great break.